Really kind of them. So I'm kind of them too.
All right, you need to label your notes. This is section 3.2. And we are going to learn about Rolle's theorem. Rolle's theorem. And Rolle's is a mathematician from a long time ago. I actually Googled his name when I was getting ready to get the stuff ready for you, and he's a very old man. Very old, very dead man, yes.
Very dead.
Very good.
So, but he came up with this theorem years and years ago, and this is what he came up with. His theorem is used to find places at which the derivative is equal to 0. So what does that mean to you? Yeah, set it equal to 0, but what does that mean if the derivative is equal to 0? What does it mean? The slope is 0. Yep, the slope. In other words, if the slope is 0, that means you have a horizontal line. Yep, there's a horizontal line at that value. But in order to find those values, 3 things need to exist, and those 3 things are that the function f of x is continuous. What does that mean?
It doesn't break.
Ongoing. There's no breaks in it. There's no, so if you're not ever dividing by 0, you're not taking the even root of a negative number. There's no situations at which the function does not exist. That's what it means by continuous. The second thing that needs to happen, by the way, it has to be continuous only over a specific interval. Hey, Tom, you can't do that when I'm talking, okay? It has to be continuous. It might not be continuous, but as long as it's continuous over the interval, you're okay. The second thing that has to exist is that the function f of x is, that's supposed to be an f, differentiable. What does that mean?
You can find the derivative.
You can find the derivative. Is differentiable. So you have to be able to find the derivative of it. If you can't find the derivative of it, then you can't do this. And the third thing that has to happen is that the value of the function at the leftmost endpoint has to be equal to the derivative at the rightmost endpoint. And if these 3 things exist, yes?
But what if it's like a sine curve or a cosine curve or something and it stops? So that f of a does equal f of b. Type thing. You know what I'm saying? Like this value at a equals the value of b.
Yep.
It just curves.
Yep.
How would that apply to that? The slope is supposed to be 0.
Well, if you're talking about like a sine or a cosine curve, you would have a situation like this. So the value that you might be searching for is this value right here, which has a slope of 0.
Oh, okay, that's what it is.
Yeah.
Okay. Then the function. Makes sense. Thank you.
All right, so if these 3 things exist, then there is at least one C value such that the value of the function is equal to 0. And now I'm second guessing myself right now, you guys. Hold on.
F is c. How do you go to
Yeah, this is supposed to be the derivative. I thought it was. I missed that in my notes, and I was second guessing myself. Okay, good. All right, so the derivative is equal to 0. In other words, the slope is equal to 0. All right, so these 3 things have to exist first in order for this to be true. Are you ready for an example? Sure.
Sure, Tim. Take it away.
I know.
2, a parabola, as long as that parabola, the interval that they give us, as long as the high point or the low point falls within that interval, then this is kind of like a no-brainer. But we're going to start with something simple, or work up to something a little bit harder. So we have to find out. First of all, is this a continuous graph?
Yes.
Why is this continuous?
Parabola.
Parabola. Of course it's continuous. There's nothing in there that would make this have a hole or a gap or something in the graph. All right, so the next thing we need to do is figure out whether or not we can, actually I think what I'm going to do, you guys, is I'm going to make a little checklist over here on the right-hand side. Remember I said there were 3 things that had to exist? Does the first thing exist?
Yes.
Is the graph continuous? Yes. So I'm going to put a check next to number 1. Number 2, can you find the derivative? So can we find the derivative?
Yeah.
F of x is equal to 2x minus 3. So the second, this is number 2. Does the derivative exist? Yep. And this, is the derivative continuous? Are there any breaks or holes or gaps or anything, any issues with our derivative?
No.
There are not any, no. So the second situation exists. The third thing that had to be true was f of 0, not f of 0, f of a had to be the same thing as f of b. So in this case, what we need to do is figure out whether or not when we plug in 0 and 3 into our original function, do we get exactly the same answer?
Yes.
So what we're going to do is try f of 0. So if you plug a 0 into your function, what do you get out of it?
-3.
2.
Right? So 0 squared. Oh, are you using this one?
Oh.
You got to go back to your original. Okay, go back to your original function. Plug in a 0. 0 squared minus 3 times 0 is 0. Plus 2 is 2. Okay, we got okay. All right. We also need to check 3. Does it work? And I'm going to do the math here really quickly. We have 3 squared minus 3 times 3 plus 2. Well, 3 squared is 9 minus 9. So does f of a equal f of b?
Yes.
Okay, so the third issue exists. All right, so our job now then is to figure out what is that value of c that has a slope that gives us a slope of 0. So what you're going to do is take your derivative, you're going to put it equal to 0, and solve for x. You guys should be able to do this in your head. What's x? 3 halves.
Yeah. That's what I'm.
Same thing, right?
Yeah.
No, I'm just joking. It's not the same thing. So that is our value of x, or c as it was called in our definition, that will get us a slope of 0. Yes? Yes.
Is that it?
One more example.
No, like that's all you have to do.
That's all you have to do.
Wait.
Yep.
So you're trying. Right.
What do we get?
Right.
Now sometimes though, Rolle's theorem won't work because it doesn't meet those 3 things. So you have to check. You guys, I feel like I am talking to very young children today. Can you please not talk? You have to check to make sure that'll be, in some cases, will be the hardest part. Is just deciding whether or not those 3 constraints are met.
So if it doesn't,
Then you can't do Rolle's theorem. You can't stop. As soon as one of these things doesn't work, you stop. You can't do anything with it. Okay? Because Rolle's theorem doesn't guarantee then that you're going to have a slope of 0 there. Those things have to exist. Yes.
So then do you do not exist?
Yep. You say Rolle's theorem does not apply. Don't write does not exist because it doesn't mean that it doesn't happen. It just says that Rolle's theorem is not enough to assure you that it does work.
So but Roll's theorem doesn't apply.
Yes. Rolle's theorem does not apply. Yes, Joey.
If it doesn't apply, he wants to keep going further.
Nope. I want you to stop.
Well, I mean,
To be honest with you, I really don't know.
Go on with what?
there's something else. Are we only be focusing on Rolle's theorem?
Just the steps, yes.
Today, yes. Only Rolle's theorem. Yep. Now, if I asked you to do something else like find the extrema, then you can go back and do what we talked about with finding extrema. But in this case, we're just going to be talking about Rolle's theorem. Okay?
Okay.
Yes.
So So on the test, will it be like that? Like, will it just be find extrema, Rolle's theorem, or will it be a problem in general and you figure out if you can
Oh, no. I will tell you what I want you to do.
Oh,
So if I want you to find the extrema, I will say find the extrema. If I want you to use Rolle's theorem, I'll probably word it something like determine whether or not there is a value in the given interval that has a slope of 0 using Rolle's theorem. I would specify to you that you need to use his theorem. Okay? All right, one more example. F of x equals x squared minus 4 over x minus 3. Over the interval -2, 2. So, does situation 1 occur? Is it continuous? Is it going to be a continuous graph? Okay, what makes this not continuous?
You can divide by 0.
Yeah, we've got a 3 here on the bottom, and 3 minus 3 would get us a 0 on the bottom. Why is it not a problem in this problem, though? It's only from -2 to 2. 3 falls outside of the interval. Are you with me here? So number 1, and you might want to make a note of this, number 1 exists, and I'm going to say because 3 does not fall in the interval.
so if it was a 2 on the bottom, then we would stop.
Then you would stop.
So it was 2 or -2, right?
Well, -2, if it said x minus 2 and you plugged in a -2 into there, you would have -2 minus 2, which is -4, which is okay. So the only issue would be is if x was a positive 2. Okay? All right. So number 1, situation exists. Number 2, we have to find the derivative. So is it derivatable? That was supposed to be funny. Let's find the derivative. What are we going to use, you guys, to find the derivative? Quotient rule. So I take the denominator times the derivative of the numerator, which is 2x, minus the numerator times 1, the derivative of the bottom, divided by x minus 3 squared. Which is equal to? So yeah, we're going to clean this up, distribute in. We're going to get 2x squared minus 6x. Yep. Minus x squared plus 4. Yep. Divided by x minus 3 squared. Alright, which is equal to 2x squared minus x squared is 1x squared minus 6x plus 4 divided by x minus 3 squared. Okay, so are there any issues here in the derivative? Are there any holes or okay, there is one. What could I put in here that would make this not be derivatable over our interval? 3. But again, the 3 does not fall in the interval, so we don't need to worry about it. Yes?
Sorry, I just got confused. Why did you not put the 2x squared? You just put x squared.
2x squared minus x squared.
Oh, okay, never mind.
Got me 1x.
Thank you.
Okay. Alright, so situation 2. Number 3, we got to figure out whether or not those endpoints work. So step 3 is that we need to figure out what is f of what, you guys?
-2.
F of -2. And then we also need to calculate f of 2. And do not check the derivative. You have to go back to the original function. So I think the easiest, quickest way to do this, you guys, would be go to y equals, type in your original function, making sure that you separate the numerator from the denominator with a set of parentheses. Make yourself a table, and I need 2 answers.
Zero.
Yeah, you get 0 and 0, right?
No.
Alright, so f of negative 2 is 0, f of 2 is 0. That means f of a equals f of b. So Rolle's theorem applies. So all we need to do now is figure out what is the value of x that will make the derivative equal to 0. So I'm going to start on and I need someone to read this to me because I'm not going to have this in front of me. So the derivative we have to put equal to 0. F of x equals x squared plus 4 over x minus 3. Ignore that, you guys. X minus 3 squared. And we have to put it equal to 0. Alright, so remember, you guys, when you are trying to put this equal to 0 and you have a fraction, do you remember that I've talked about this 2 or 3 different times now? Just get rid of the bottom. All you're doing is getting rid of the bottom. So I'm going to jump right to this step. What we really have going on here is that x squared minus 6x plus 4 is equal to 0. Yeah.
Can you only get rid of the bottom if it's equal to 0?
Yes. If it's equal, yeah. And the reason is because what I really did was I multiplied this side by x minus 3 squared, which canceled these out. And then when I multiply over here, the 0 just wipes it out. Okay. Is this factorable?
Yeah.
Are there any 2 numbers that will multiply to give you 4 and add up to negative 6?
No.
But we still need to figure out what x is. So what are we going to do?
Quadratic formula.
Yes, the quadratic formula. So listen, you guys, Melissa just said this, and I see this so often, but I'm actually glad you said it because we need to address this. You have an x squared and an x. You can't solve it like you would solve a linear equation or even a quadratic equation without that x in it. If you have 2 x's in 2 different places, you can't just move that over. That is an illegal algebraic move. So you're going to need to use the quadratic formula.
Can you just cheat?
No. Get.
Take it.
Oh, it's a cheat?
No. You know what? He's saying, can you just type it into your calculator and figure out where you get 0, but this is calculus. We're not going to do that.
But you know.
Thank you, Mr. Kuhn.
I knew I liked these.
Negative b plus or minus the square root of b squared. You guys, this should be refreshing. After all the stuff you guys have been doing. What is the opposite of b? What's the opposite of b? 6. Plus or minus the square root of. Now, I like to just do all of this part in one step on your calculator. So if you could just do b squared minus 4ac, this is called the discriminant. If you could just calculate that over on the side or in your calculator or something. B is negative, so we have negative 6 in parentheses squared minus 4 times the a value, which is 1, times the c value, which is 4. You get 20?
What's up?
Divided by 2 times a is 1. So we have 2 times 1. So those are your answers. But that's weird and awkward and ugly. So we need to, remember what we do to that?
Tree.
Tree.
Oh.
Let's try that again.
Tree.
We do a tree.
522 million.
Yeah.
I like trees.
I do too. I think they're fun.
Oh, I'm sorry.
We can't be friends anymore.
2 and 10 is 20. 10 is 2 and 5. Those two are a pair. Do you remember that?
Yeah.
6 plus or minus
2 square roots of 5.
2 square roots of 5 over 2. And now you can only clean this up if that 2 and that 6 and that 2 are all divisible by the same number. What number can I divide into 6, 2, and 2? 2. So if I divide 2 into 6, I get 3 plus or minus the square root of 5. And that is your final answer. But one of them or both of them might not fit in our interval. So we have to check whether or not these decimal values fit into our interval. So quickly take 3 plus the square root of 5 on your calculator. What is 3 plus the square root of 5? 5.2. That doesn't fit in the interval. Are you with me here?
Yes.
So do 3 minus the square root of 5. 0.7. So the only answer that is going to work was the one where we actually subtracted them. That is the value on that graph that is going to give you a slope of 0. A horizontal line, yes. Say that again. Oh, you mean negative here? I did 3 plus the square root of 5, and it got me some number that didn't fall within my negative 2, 2 interval. But then this one did fall within the negative 2, 2 interval. Okay? Yes.
So if it's a pair, it goes outside of the.
Yes. If it is a pair, it goes outside of the radical. You definitely are going to be revisiting the quadratic formula in the stuff that we're doing today. Okay? Yes.
And if there's more than one pair, you multiply those pairs together, right?
Yes. So let's say you guys, Joey just asked this. If there's more than one pair, in other words, it was a 2 and a 2 and another 2 and another 2, we would have 2 pairs of 2's. So those 2 pairs would have to be multiplied. So it would be 2 times 2. Then we'd have 1 left over underneath the radical. Leftovers go under radicals. The pairs get multiplied.
Absolutely all different. So it wasn't.
If they're all different numbers, then you just multiply them. You go back to what you started with. Yeah, you just multiply them all and leave one answer underneath the radical. Okay? All right, we do have a homework copy today, so I want to